Hello, dear students. Today I am here with new periodic properties, electron gain enthalpy, and electronegativity. How many of you are aware of what electrons are? Too trivial a question, isn't it? But what a electron gain enthalpy is? Now that's a tough one, isn't it? Well, not anymore. In this video, we will look at the concept of electron gain enthalpy and electronegativity and discuss it in greater detail. Let's see what electron gain enthalpy is. This word is new for you all, but you will find that this is quite related to the topic which you have already studied in class 10, electron affinity or affinity energy. If you can remember that, electron gain enthalpy is same as electron affinity, but why this term is now used? Actually, electron affinity was defined at absolute zero. Okay, therefore at any other temperature, the heat capacities of the reactants and products must be taken into account. Okay, this is why it is more appropriate to use the term electron gain enthalpy rather than electron affinity. So, electron gain enthalpy of an element is the energy released when a neutral isolated gaseous atom accepts an extra electron to form the gaseous negative ion, that is anion, and we can denote it by delta EgH. Okay, delta, for the change we just make this symbol delta EgH. This is our electron gain enthalpy. Greater the amount of energy released in the process, higher is the electron gain enthalpy of the element. The electron gain enthalpy of an element is a measure of the firmness or strength with which an extra electron is bound to it, and it is measured in electron volts per atom or kilojoule per molecule, and it can be an endothermic or exothermic reaction when you add an electron to the atom. If you remember your the last topic which we have discussed, ionization enthalpy, that is ionization potential. Okay, in ionization potential, we express the energy supplied to the atom to remove successively 1, 2 or more electrons and thereby produce cations. Okay, in ionization potential, cations was formed. In the concept of electron gain enthalpy, we refer to a reverse process. Thus, we have an energy associated with the addition of an electron or even more electrons in succession to a neutral atom. Let's see how we can define it by writing a simple equation. This is a gaseous atom. Okay, we are adding electron to it. What will happen? An ion will be formed and energy will be released. And this released energy is the electron affinity. And as energy is coming out, we will call it a exothermic process. Why? Since energy is released in it. So by this we can explain the electron gain enthalpy. You can see a neutral gaseous atom. To a neutral gaseous atom we are adding electron, an ion is being formed and energy is being released. So this process by which the neutral gaseous atom adds an electron is an exothermic process, since energy is released in it. And since electron gain enthalpy represents the energy released, it is represented with a negative sign placed before it. And electron gain enthalpy just define, this is your first electron gain enthalpy, since it corresponds to the addition of one electron only. And in the process of adding an electron to an anion, to the anion which is formed here, now if we will add electron to this anion, electron is added to it, what will happen? To add this electron to this anion, we have to give energy. As we are giving the energy before, then it will be a endothermic reaction, and then anion will be formed. So in this process of adding of electron to an anion, against the electrostatic repulsion between the electron being added and the negative charge of the anion, this is negative, this is negative, negative will what it will show? It will show the repulsive force. Okay, repulsion will occur here. And the energy, instead of being released, will be supplied. Here energy was being released, but here we are giving the energy to the system, then only electron is being added to it to form another anion. So energy supplied in the process to convert a anion, A negative to A2 negative, is called second electron gain enthalpy. And since this second one is the energy is being absorbed, so it is given with a positive sign. First will be negative, second will be positive. First is your exothermic, second is your endothermic. One example is given in your book for oxygen. Oxygen in the gaseous state, electron is being added, an ion is being formed, and delta Eg H1 is given minus 141 kilojoule per mole. Let's see its second reaction. When to O minus we are adding the other electron, it is forming O2 minus, and this delta Eg H is going to be now positive, 780 kilojoule per mole. Okay, now let's see some facts about the electron gain enthalpy. Energy is released when an electron is added to the atom, therefore the electron gain enthalpy is negative. Okay, this is clear, this only is the definition. The electron gain enthalpy for halogens is highly negative because they can acquire the nearest stable gas configuration by accepting any extra electron. As you know that halogens are one electron less than the noble gas configuration. So as the electron will be added to them, they will acquire the stable noble gas configuration. So the electron gain enthalpy is highly negative. Now what about noble gas configuration? Noble gases have large positive electron gain enthalpy. Why? Because they are completely filled. That's why they are inert or non-reactive. So what will happen if we will try to add the electron to any of the noble gas configuration? What will happen? A new principal quantum energy level will be formed, and this will produce a highly unstable electronic configuration. So the electron gain enthalpy for noble gases will be positive. What are the factors affecting the electron gain enthalpy? Number one is size of the atom, atomic size. Smaller the size of atom, greater is the electron gain enthalpy. This only is to be remembered, that smaller the size of the atom, greater is the electron gain enthalpy. Next factor which affect is the nuclear charge. Nuclear charge, electron gain enthalpy increases as nuclear charge increases. Okay, as nuclear charge increases, electron gain enthalpy also increases. Third is electronic configuration. The elements having stable configuration have very little or no tendency to accept further electron. Now let's see the variation of electron gain enthalpy in the periodic table. So in group what will happen? In general, electron gain enthalpy becomes less negative in going down a group. Their values are highly negative for halogens. Here you can see a table I have provided, the electron gain enthalpy of halogens. Here one thing you can notice, that chlorine is having more negative value than fluorine. Here your question will be framed, give reason. So I'll tell you about it. First let's see the variation in a period. In a period, in general, the electron gain enthalpy becomes more and more negative on moving from left to right in a period. Why? Due to decrease in size and increase in nuclear charge. Okay, due to decrease in size and increase in nuclear charge. There are few exceptions for electron gain enthalpy. Number one, electron gain enthalpy of second group, alkaline earth metals, beryllium, magnesium group, is positive due to completely filled s orbitals. Okay, next is electron gain enthalpy of nitrogen atom is positive due to its half filled p orbitals. You can see that whenever the electrons are shells are half filled or completely filled, means a stable state the element has acquired, the atom has acquired the stable state. There if you will try to add the electron, you have to give the energy, and this will be endothermic reaction, and here you will get a positive electron gain enthalpy. And the electron gain enthalpy of halogens is most negative among all elements, but electron gain enthalpy of chlorine is more negative than fluorine. Why? Due to strong inter-electronic repulsion in small size of fluorine atom, in which the additional electron is attracted towards the nucleus by lesser force. The electron gain enthalpy of noble gas is positive. Why? Due to their stable electronic configuration. Okay, there are a few questions which is to be answered and for give reason. So this was all about your electron gain enthalpy. Next I will discuss about the electronegativity.